Hello there. Now we have a question on Young's modulus. In the current 2022-2024 syllabus, it would be in chapter or topic number 6.1. So what we have here, an elastic cord of an unstretched length 16 centimeters. So we can actually highlight this, indicating that this would be the original length, and a cross-sectional area of 2 times 10 to the minus 6 meters squared. So be careful because here the length is given in centimeters whilst the area is given in meters squared. So some sort of unit conversion to ensure that the units are consistent is required. Both basically it is held horizontally by two smooth pins at a distance of 8 centimeters apart. So basically it just creates a loop. 8 plus 8, it will be 16 centimeters. So here will be an unstretched cord where it would correspond to the original length. Now the cord obeys Hooke's law. That means the force acting on is basically directly proportional to the extension of the cord. And then a load of mass 0.4 kilograms is suspended centrally on the cord. The angle between the two sides of the cord supporting the load is basically 60 degrees because we can assume here all have the same length, 8 centimeters, 8 centimeters, and 8 centimeters here as well. So automatically we know that this 8 centimeter would be our extension X because the original length is 16, and when it is stretched, then the total length here would be 24, whilst the original length is 16, so the extension will be 8 centimeters. What the question is, what is Young's modulus of the cord material? So just a brief recap, Young's modulus is basically the property that represents the material. So you get E is equivalent to stress over strain. So stress is force over area, whilst the strain is basically the extension over the original length. So here you get extension over the original length L. So we have L 16 centimeters, which we can represent L is equivalent to 0.16 meters. So we convert it straight away, where X is equivalent to 0.08 meters. So that is basically L and X, which of course you can just take the ratio in order to eliminate the uncertain unit conversion. Then again, okay, so we have here A. So the information that we have here right now is L, A, and X. Do we have F? Is F equivalent to the mass or the weight? W equals to mg here? No, it is not. Why not? Because what we have here, the force is basically the mass, the weight, but what we want is basically the tension. Okay? The tension that causes the cord to extend itself. So we can actually visualize this by using a force diagram. So here you have here the weight equals to mg, which is 0.40 kilogram multiplied by 9.81 meter per second squared. And then here you got tension 1 and tension 2. So this tension can actually be resolved into its vertical component T cos 30 degrees. How do you know it's 30 degrees? Because the angle here is 60 degrees. So they have the same length. So basically it's all 60, 60, 60. You can just divide it equally. You get 30 degrees here. And then you have 2 multiplied by 2 because you got tension on the right hand side as well as the left hand side. Therefore, we can calculate 2t cos 30 degrees is equivalent to the weight. So we have to find out what is the value of the tension here in order to plug into our Young's modulus equation. So just a brief calculator. Take 0.4 multiplied by 9.81, 0.4 kilogram times 9.81 divided by 2 and divided by cos 30 degrees. You'll get your answer to be the tension right now is 2.27 newtons. Now this would be the value of your force. So now you can calculate the Young's modulus. E is equivalent to T LAX. So T tension, it will be equal to 2.27 multiplied by the original length, which is 0.16 meters. this one is in newtons, divide by the cross-sectional area, 2 times 10 to the power minus 6 meters squared, multiplied by x. Be careful, x is basically 0.08 meters. So here 2.27 multiplied by 0.16 divide by 2e minus 6 divide by 0.08. So you get your answer here to become 2.27 times 10 to the power 6 pascals. So the closest answer up to two significant figures will be 2.3 times 10 to the power 6 pascals, where the answer is C.